Hi, I'm Seth, and in this video, I'm going to talk about how to choose a statistical analysis software. There are many programs out there, but I'm just going to focus on three that I'm familiar with, which are Excel, SPSS, and R. These are pretty commonly used in psychology, which is where I work. Now, sometimes people will have a favorite that they think is just perfect in every way, and they'll trash talk all the others. But the truth is that they all have strengths and weaknesses, and I would argue that which one you use should depend on what you're doing and in what context. In this video, I'm going to assume you know almost nothing about any of these three programs, and my goal is going to be to help you figure out where you want to start. To do that, I'm going to briefly review each of these programs, and then I'm going to do a quick demonstration in each of them. I'll start with Microsoft Excel, which may be the most familiar to most people. This is a spreadsheet program where data is displayed in columns and rows. You can run a variety of basic analyses and create many types of graphs. Compared to the others, I would argue that Excel is easier to learn. It's also probably going to be more familiar to people in organizational settings. However, Excel is not designed just for statistics, and consequently, you may find that it can't do some of the more sophisticated things you want to do, at least not without a lot of extra work to get it there. However, if you're just getting started with statistics, Excel is going to be able to do pretty much anything you need. The interface is user-friendly. You can click on things, drag them around, highlight cells, and there are useful tool packs you can download, like the analysis tool pack, that will allow you to do some statistical analyses pretty quickly. I would say Excel is probably a good intro starter program. With that said, there are also people who are masters of Excel and do all sorts of advanced analyses using this program. IBM SPSS stands for Statistical Program for Social Sciences. In many ways, it's similar to Excel, at least in how the data is displayed in a tabular format. Unlike Excel, SPSS was designed specifically for statistical analysis, so it can run many more analyses and create more types of graphs right out of the box without downloading anything additional. Many people like the point-and-click format. You can see that if you want to run a particular analysis, you can go through these menus and select what you're trying to do. Here we're saying we want to analyze something, then we're going down and clicking correlation, and then a certain kind of correlation. A lot of social scientists like to use SPSS, and they will often create macros that you can download for free and use to run even more advanced statistical analyses. There's also quite a bit of customization you can do once you start getting into coding with SPSS syntax. One thing to note is that both Excel and SPSS have to be paid for by someone, whether that's you or your boss. So that's something you got to factor in. The third option I'm going to talk about is R and RStudio. R is a statistical programming language. Like SPSS, it was designed specifically for the purpose of statistical analysis. RStudio is an interface that makes the language more accessible and easier to use. What you see in this image is actually RStudio. Nice things about R include that it is completely free. It is basically infinitely customizable. You can run any statistical analysis. You can create any type of graph. And if you ever find yourself needing to run an analysis that there is no existing code for, you can just write your own code to run the analysis. R is what I use to run all of my own analyses, and I consider it the best of these three options. But I'm going to be completely honest with you, it is harder to learn than the others. Sometimes people will scoff when you say that, but those people are either confused or trying to convince you of how smart they are, because it absolutely is more work to learn at first, especially if you don't have any prior coding experience. So whereas in SPSS, you click through menus to select the analysis you want to run, in R, you write code to select the analysis. What you're doing is speaking directly to the computer and telling it what to do. This is, frankly, more difficult, but far more powerful. And once you have familiarized with R, it becomes much faster than the other options. Here's a quick review. Excel has, I would argue, the most user-friendly interface. It is very popular in organizational settings. In fact, if you're going to be doing analyses in a business context, you may be expected to use Excel. It is less flexible and customizable than SPSS and R, and it costs money, and it can get expensive. SPSS also has a user-friendly interface, but it is more focused on statistics. This is going to be familiar to many social scientists if you're in that arena. In fact, if you're going to graduate school, you may be expected to use SPSS. The downsides are that SPSS is less customizable than R, and like Excel, someone's got to pay for it. The benefits of R are that it is free and infinitely customizable. It will be familiar to many social scientists and many researchers in organizational settings. If you think you might end up doing analysis in more technical organizations, there's a chance you'll be expected to know how to use R. The downsides are that it's less intuitive to use and it's more difficult to learn at first. If you like coding or are willing to learn, I recommend that you use R primarily. I consider it the best by far, and like I said, I run all my own analyses almost exclusively in R. If you plan to go to grad school, I recommend you either use SPSS or R primarily. If you don't like coding, don't plan on going to grad school, etc., Excel is probably what I would recommend for you. So that's a quick overview, but I think it could be helpful to just actually see some demonstrations of what these programs can do. So let's get started with Excel. So here's a small data set. These are the number of hours of sleep that college students in a statistics course reported getting per night on average. A nice thing about Excel is that you can really interact with the data easily. We can highlight all these and sort them from smallest to largest. Notice that it kept track of the ID number and moved it along with the value as it was putting them in order. Statistics are pretty easy to calculate. So for example, we can say count equals count the number of scores. You can set up formulas to automatically calculate. So if the sample size is 27, the degrees of freedom must be 26, at least for the purposes of calculating the variance. You can say add up all the numbers using the sum formula. You can say average to find the mean, median to find the median. I'll use mode.single to find this mode, minimum to find the minimum value, max to find the max. Sums of squares, DEVSQ, variance, variance, var.s, standard deviation, stdev.s. Pretty straightforward. It's also convenient to see how these values would change if any value in your distribution changed. So for example, if this were actually 50,000, the variance becomes much larger. This also drags the mean up. It's also fairly straightforward to make graphs. We can highlight all the data that we're interested in and say insert. Let's make a histogram. It's not the most beautiful histogram I've ever seen, but we can format it a bit. Now, this will require quite a bit more cleaning up, and I just really hate that x-axis, but it's a starting place. It's not too terribly difficult to add whatever you want. Customize. Let's call this frequency, hours. I also like to use Excel to create calculators and other tools to do what I want. So for example, this is a frequency distribution generator that I made. For this simple data set, I can just plug in the values I'm interested in, and it calculates the frequencies, proportions, cumulative percentages, etc. Here's a t-test calculator I made. It's okay if you don't know what a t-test is. The point is, it's a pretty common statistical analysis, and Excel can do it. Here, I input whatever data I'm interested in, and I have it set up to calculate all these various statistics, including a t-statistic. Not significant. Womp womp. Here's a spreadsheet I created to demonstrate the concept of ANOVA, which again, it's okay if you don't know what that is. What I like about this is that Excel will randomly generate data, and then it will automatically update all of my calculations. It will even update the graph based on the new data. So far, no significant ANOVAs. Oh, there's one. Again, doesn't really matter if you know what an ANOVA is yet. Excel can do it. I'll do one more demonstration. This is a chi-square calculator that I made. So in my current statistics class, we have 4 students with green eyes, 3 with hazel eyes, 7 with blue eyes, and 14 with brown eyes. You can use a chi-square test to see how likely this particular distribution of eye colors would be if all eye colors were equally likely, which, you probably know they're not. But if we supposed every eye color were equally likely, we'd get a chi-square of 10.57. Once again, can't stress enough, doesn't really matter if you know what that means yet. The point is, there are ways to set up Excel to automatically calculate these things for you, which can be very convenient. All right, that's probably enough on Excel. Now I'm going to do an SPSS demonstration, and to be completely frank, SPSS is probably going to get short shrift compared to the other programs because I don't typically use this one, except when tutoring students who are required to use it for their class. So here is SPSS. Like Excel, the data is displayed in columns and rows. You can see we've got subject numbers right here. That's each row is a different person. We have a score for gender. Gender appears to be binary. I only see 0 and 1. We've got some sort of number indicating pay. And then we have a bunch of job satisfaction items. I'm an IO psychologist, so you're going to see a lot of job-related examples in these videos. Because SPSS is much more focused on statistics than Excel, there are these convenient windows you can use to look at different columns and see information like this job satisfaction. This third item is a numeric variable. And you can see I have it coded as an ordinal data type, whether that makes sense or not. And then we have all these menus with just loads of options for what you can do with the data. We can spot duplicate cases. You can recode variables, create dummy variables, replace missing values. This is all stuff that can be done in Excel, but it's a lot more straightforward to just immediately access it through these menus in SPSS. Under the Analyze tab, there are all sorts of analyses you can do. Descriptive statistics, create tables, t-tests and ANOVAs, correlation, regression, factor analysis, chi-square. So for example, let's do a reliability analysis for these job satisfaction items. Doesn't really matter if you know what that means. I just want to show you what the results look like. So in SPSS, it gives us windows, and we select all the values that we're interested in. All the variables we're interested in. Then you can specify certain options. Let's see, correlations, descriptives, all sorts of stuff. You don't need to know what any of this means yet. A new window appears, and there are tables and statistics. The reliability of this scale is 0.77. We have correlations between all the items. We can see how the reliability would be improved if a particular item was dropped. All sorts of fun psychometrics and statistics. And SPSS can also create, among other things, graphs. Let's just plot gender for simplicity. A new window appears, and as I had mentioned earlier, we're dealing with binary gender, so I actually don't know which is which, but we've got them coded as 0 and 1, and we've got the frequency on the y-axis. Now, you might want to make this a nicer, prettier, cleaner graph, and there are ways to edit it. You can add a title, format it however you like. All sorts of fun editing options here. Now, as I promised, I'm going to give this one short shrift because I don't really use it that much. There are people who are SPSS wizards who, if they saw this, they would say, no, you're overlooking all these great features. And I admit that, yeah, I am. Hopefully, though, this gives you an idea of what it's like to use SPSS, and you can get a sense of whether this is how you might want to deal with your data. Well, before we go, let's do a quick t-test. We did a t-test in Excel, so I guess I should do one here as well. Since gender is binary, we'll use that as our grouping variable. Let's see, what do we want to compare? Let's see if job satisfaction differs depending on gender. Once again, SPSS pulls up a new window, and you can see descriptive statistics about your data. It's automatically trying to check certain assumptions of the analysis. It's reporting a t-statistic, a p-value, the mean difference, confidence interval, Cohen's d, all sorts of fun statistics that you will learn about if you don't know them already. So, like Excel, this can be much faster and painless compared to solving these calculations by hand. Now I'll move on to my personal favorite, R, and I'll try not to go too long on this because this is where I just sort of geek out. This is RStudio, which, as I said, is a program you can use to make it easier to use the R programming language. As with Excel and SPSS, I'm not really trying to show you how to do things. I'm just trying to show you what is possible, even if you aren't really familiar with what I'm showing you yet. So this R script comes from a presentation I sometimes do for people who are unfamiliar with R, just to show them what all kinds of things you can do. Like Excel and SPSS, R is capable of doing basic calculations like 2 times 3 is 6, 4 divided by 2 is 2, 2 to the third power is 8, square root of 9, 3. It can also calculate statistics. For example, the mean of the numbers 1 through 5 is 3, as is the median. It can find the variance of those numbers. It can find the standard deviation of those. R can also display data in a spreadsheet format, similar to what you saw in Excel and SPSS. So here we have data from the General Social Survey, and you can scroll through it and see that it's displayed in tabular fashion, not unlike Excel. So it's a different way to do many of the same things. Whereas we would click through menus in SPSS, we can run our statistics by running these lines of code like that. We can calculate correlations between variables. We can create a correlation matrix. These are not things that we couldn't do in the other programs. It's just a different, more customizable way to do it. Regression analysis, all sorts of fun statistics. We did t-tests in Excel and SPSS, so you won't be surprised to know we can do them in R as well. Uh-oh, there's a difference in how happy married versus unmarried people are. And then, like the others, we can create visuals. I prefer to make my graphs in R, even if I do anything else in Excel. I just find this much more workable. I can make it look the way I want it to look pretty easily. But I mean, with that being said, you can see it's a more complicated process to write this code than it was to just click through some menu options. The nice thing, though, is now that I've written this code, I don't ever have to write it again because I can copy paste what I've done before and just tweak the details. It's not too horribly difficult to customize these to look the way you want them to. Something else I really like, and which I mentioned before, is that if you need something that doesn't already exist, you can create it. So here is a set of visualizations that can be used to evaluate how well the assumptions of a linear model are met. I've said this 50 times already. Don't worry about what any of this means yet. The key takeaway is that there wasn't already code that creates these 8 graphs stacked like this with this color scheme and these titles. I just wrote the code for it because it didn't exist, but I wanted it. And that's what I love about R. If there's something that you want and it doesn't exist, you can just create it. You can also run more advanced analyses, structural equation modeling, meta-analyses. So this single line of code is a meta-analysis. That may sound more impressive once you know what that means, but maybe not. And then I guess I'll show you one more thing. We can use tools like R Markdown to create reports. So for example, for my dissertation, I had people complete a personality test as part of the study. And to sweeten the deal for them, I sent them their personality results. Afterward, I created a separate PDF report for each individual summarizing their personality results, which may seem like a huge pain, but it's actually not so bad. So I created what's called an R Markdown file, which just has all the things I want to go into the report. Like I want it to say, during this study, you completed a personality test. Here's what you need to know about personality. And then I instructed it to report each person's personality results, including their percentiles, and also some graphs to show where they lie in each distribution. And then I just ran these few lines of code, and I guess I'll just let you see what happens when I run them. So you can see over here what's going on. R is creating a PDF report for each person that I collected data from. Let's take a look at this first one and see what we've got. Okay, so we're getting a PDF report, and you can see all the things I told it to say. It's saying it. It's calculating their score for extroversion. This person lies at the 96th percentile. If we assume a normal distribution. It's also broken down by facet of the scale. And we have this for all 5 of the big 5 personality traits. And we have links to other resources where they can learn more about the test. So this is a pretty nice little report that's generated with little effort, relatively speaking. And look, I've now got reports for 18 people and counting. So if this was the first time you've seen R, you'll probably have the same impression that many people have, which is, wow, this is extremely powerful, and wow, this is going to be kind of a pain to learn at first. And both of those are correct. Now, as I said at the start, these are only 3 of many different programs you might use. I've done a bit with SAS, Python, and GraphPad, but I'm less familiar with the other tools here. But I've heard good things about them, and I've heard that some of these are especially good for certain purposes. Even as obsessed with R as I am, I might switch over to something else for a particular purpose if the other tool is better for that purpose. And I think that's the key takeaway to all of this. You want to ask yourself, what is most appropriate for what I'm going to be doing in the context I'm going to be doing it? And I would say select the tool that's best for a particular job, even if that means jumping between different tools for different jobs. All right, that's it. I hope that was a helpful introduction to Excel, SPSS, and R. If you have specific questions about this or other statistics-related topics, don't hesitate to reach out. See you later.